So today we're going to learn about calculating bond energy. We'll begin with writing a balanced chemical equation for combustion of methane. So we begin with methane and we add oxygen. That gives us CO2 and H2O. As you see, I've also balanced the equation. So it's a completely balanced combustion equation of methane. The next thing that we want you to do is to draw Lewis dot structures for the reactants and products. And this is why we had you practice yesterday drawing structures for all substances using the rules for Lewis dot, because you will be repeating this for this topic. So I have methane here. I have oxygen. See how I've drawn two oxygen molecules? Just as I've balanced in the equation. It's important that you repeat the coefficients in the drawing. So actually every bond is accounted for when we do calculations, which you will see later. On the product side, we have one CO2 and two water molecules. So if you were in classroom, we would have performed a demo for you exploding methane bubbles, which is a really cool demo that you missed because we are home. But since we still want you to see it, here's a video from last year that I want to show you. I'll do it one more time. It's been really quick. Another time. Okay, so was this reaction exothermic or endothermic? So we set something on fire, so it's releasing energy. So yes, it was exothermic. So chemical potential energy of substance results from the arrangement of atoms and strength of the bonds that join them. So to calculate the heat of reaction, which is the enthalpy, it's the difference between the products and the reactants. In exothermic reaction, there's more energy stored up in the reactants than products. As the products are formed, the net energy released to the surrounding, hence heating up the surrounding. So we saw that in the graph last week that in an exothermic reaction, the product was lower than the reactants. So this is the bond energy values that will be given in every worksheet, every test, every quiz that you take from now on. You're not required to memorize this. It'll be always provided to you. So energy is required to make and break a bond. So we saw that for an endothermic reaction, for the bond formation, it's exothermic. For bond breaking, it's endothermic. So when energy is used to break the bond, the value stays positive. When the energy is released, it's negative. So the example that you have in the notes today is the combustion of methane. So I've repeated the same thing from the slide one here. You have the reaction equation and you have the Lewis structures. If you see, I have highlighted the bonds. This is to help us in calculation in these tables. So we're going to look at the bond broken first on the reactant side. So if you see, I have 4 CH bonds. So the CH bonds, the 4 CH bonds come from here. And the value for it, let me go back to the previous screen. The value for it is 413. And that comes right here. So I have 4 times 413. Then I have 2 O double bond O bonds. So let's go back. And I have O double bond O, which is 614. And that's the one I have here, 2 times 614. I multiply this, add the total, which I get it as 2880 kilojoules. Kilojoules is the unit. On the product side, I have C double bond O, and then I have O and H bonds. So how many C double bond O do I have? I have 2 of them. How many OH do I have? I have 4 of them. So that's how I fill the table. Okay, again, the 799 comes from this table right here. And OH is, where is it? Here, 467. Okay, so let's go back here. We do the same thing again. We multiply and add. If you see, I have a negative sign here because energy release will always be negative, and that's why it ends up, your product side ends up being negative all the time. So how do I calculate the net energy? I do total energy required plus released. But since this is negative, you're always subtracting it. So it'll be reactants minus the product. If this is negative, if your final answer is negative, it's an exothermic reaction. If it's a positive value, it's an endothermic reaction. The graph, just like last week, reactants begin at a higher value, activation energy goes down, releases energy, and those are your products. This is your heat of reaction, the difference between your products and reactants. So what are the things that we have to keep in mind? It's important to draw Lewis structures properly. O single bond O is very different from O double bond O. You got to balance the equations and draw the Lewis structure as many times as the coefficient. If there are 2 water molecules, draw them twice. Look for the correct bond value in the chart. I've made this mistake before. Don't look at C bond C and write the value when you're looking for C bond O. Multiply the number of bonds correctly. Use a highlighter. That really helps me. Energy release will always be negative. So your product side will always be negative. So hence, the net energy will always be subtracting. Don't forget units in your final answer. kJ, kilojoules. And that's it. I hope this helped you. Make sure you fill in the notes and place it in the science folder. Thank you.